Voice of the Sea, learning from experts across the ocean.
Welcome to Voice of the Sea.
In this episode of Voice of the Sea, we're at the Pacific Aquaculture and Coastal Resources Center at UH Hilo, where they grow oysters. First, lead researcher Maria Haas shows us edible oysters. Then we take a look at pearl oysters.
So this is the Pacific Aquaculture and Resources Center, and it used to be the wastewater treatment plant for Hilo.
Oh my goodness.
And then it was decommissioned for quite a few years, and eventually the county and state gave it over to the university to run as an aquaculture center. These used to be the wastewater treatment tank, and now we use them for various things, including growing some fish, and also as a place to grow out oysters.
So was there a lot of cleanup that you had to do to transition it from wastewater treatment to food growing place?
Yeah, since it was a brownfields project, so all these had to be completely cleaned and resurfaced so there wouldn't be any contaminants left. And We've had everything tested, it's very safe, so we can actually use it to grow food animals like oysters and fish. Let me show you some oyster spat.
Oyster spat.
Oyster spat are just juvenile oysters. And these bags that you see, if you can see these really tiny oysters, this is just window screen that we use a bag sealer on to make little bags. It's really cheap. And after they've gone through metamorphosis, in other words, they turn from a swimming larvae into a sedentary animal, this is what they look like. And so we'll grow them up in here till they're between 2 and 5 millimeters. And then some of these go to oyster farmers in Washington. And some of these go to the fish ponds to do oyster work in the fish ponds.
So you put the larvae inside of the bag?
Well, actually, I'll show you later, but they actually are settled in a different tank. So when the larvae reach the stage at which they're going to stop swimming and attach themselves, we actually force them to attach themselves to really tiny grains of oyster shell. So that they look like single oysters, not really attached to anything except that little chip. And then they're essentially single oysters, and they can be handled very easily.
Oh, okay. And then these oysters, once they grow up, they would be suitable for eating, but these you said you're going to send on to Washington.
These will go to the Washington farmers or the fish ponds. And the reason we're sending them to some Washington farmers is that they've approached us to do research for them because their hatcheries are being severely affected by ocean acidification. Because as the water becomes more acid, the little larvae can't actually form their shells. It's essentially dissolving the larvae, just like it dissolves coral. So, it's one of the bad impacts of ocean acidification. This is Brian Colville, who's our hatchery technician. Actually, he's serving as our acting hatchery manager right now.
This is what we had a problem with our oysters once they reached a certain size, once they were dying, so we didn't have enough water inside to satisfy them, so we kind of devised this system. Maria helped me figure it out, but this is what we've devised, and we need to clean this off a little bit, but it works pretty good at raising oysters, so that's what really matters.
So what do you tell people that you work on? I mean, oyster spat sounds kind of funny. How do you explain that? We spawn the oysters, we raise them up until they're ready to be put out in Mother Nature, and so we're just taking care of them in a nursery. We're just raising them up to a certain size, giving them the food and everything that they need, and so they're stronger and ready to go out in the ocean. So we need too many oysters to satisfy what we're trying, what the market is, so we need to put back into the ocean. How did you get interested in working with the oysters?
I got a job over in Kona working out of college, and then through I heard about a job through the university, and so I got involved over here. But I always really liked sustainability, and aquaculture makes sense because the nature, we can't keep taking out of the oceans. We're coming up with less and less each year, so we need to be putting back in, otherwise there's not going to be anything left for future generations.
Can you give me any sense of scale, like how many numbers of oysters one of those bags would produce, or how many pounds of oysters we could get out of it?
In some of those bags, we sometimes have up to 50,000 oysters.
Oh my goodness.
Yeah, so there's a lot of oysters. I mean, they're all very small, they're all about that big, but I mean, if you put them out in the ocean, you come back 3 years later, and those oysters are going to have grown to take up almost this entire size of this whole pond right here. So they'll go from being in a pouch that small to covering like a tideland about the size of this
this tank, it's really kind of amazing just to see it go from so small to you see it on a microscope to seeing it just all out there and able to feed people.
I know that there are oysters that we eat and oysters that make pearls or which we use for jewelry now, and these are food oysters. So do they look different from the pearl making oysters?
All oysters are capable of making pearls. It's just that there's certain species that make them into more like the ones we desire for jewelry. Like a lot of these oysters, as they grow older, like young oysters, they don't have, they have very little, they're very young, and they usually, pearls are caused by like an irritation, and so the oyster covers it up with this little thing that it builds its shell with, but on the inside it looks different, and so eventually it forms this pearl around whatever is irritating it. So the older the animal is, the bigger the pearls are going to be.
So what I'm going to do is I'm going to show you the pearl oysters.
Oh wow, they're pretty.
And this is a strain of pearl oyster that is found in Hawaii.
So Maria, you're kind of locally famous for the oyster production or the pearl oyster production that you do.
Well, I've been working with pearl oysters for about 20 years, and most of our work actually takes place in the Marshall Islands and the Federated States of Micronesia, where the Pacific Islanders do pearl farming. So we're trying to actually bring it to Hawaii, and actually thanks to a company in Kona, they donated these pearl oysters which were produced in their hatchery. We are working on producing pearl oyster larvae here as well, and partially for student training, of course.
And they look a lot different than the edible oysters we were just observing.
Right, so that's actually because pearl oysters, even though we call them oysters, are not really oysters. They're actually more closely related to scallops, although it's a little known fact. But these are obviously the same oysters that produce these beautiful pearls that you're wearing today. Yes. Although those probably come from Tahiti, I guess.
They're from Tahiti, yeah.
Right, so our goal is eventually to produce the same kind of pearls here in Hawaii. One of the things we're generally interested in is not just producing pearls, but restoration of the species, because it's very rare right now. So we could do restoration of the populations, and that's the same for almost all the animals we work with, because here in Hawaii, most of our shellfish species have declined drastically in their population numbers.
I feel it moving.
They do move, see, it's squirting out water. It's clamping up, so we should put it back in the water. They can stay out of the water for a while, but they prefer the nice, cool, wet situation. This is the Shellfish Hatchery greenhouse where we have our shellfish program for Pack Rack. Okay, so this is the hatchery, but this is also our nursery area. So this is actually one of Brian's areas of expertise, and this is where, when the larvae is ready to stop swimming and it wants to go through metamorphosis and attach itself, this is where we do it.
So here's some of the oysters you can see swimming around. These ones we put in here yesterday. They're right there, they look like those little grains of sand. Those are millions of little baby oysters.
Wow. And these are about a month old?
These ones are about a month old, yeah. They were in those blue tanks for about a month, and then we put them in here when they're ready. And so they swim around for a little bit until they figure out that they want to go to the bottom, which is in usually a couple days before all of them find a home. Sometimes they stick to the tank, sometimes they do that, but most of them will go onto the oyster shell. The white stuff on the bottom is all oyster shell. So each one will stick to a different one of those grains of sand, and eventually you'll have oysters that are all in there. We take the oysters and the sand and everything, and we pass it through these screens here, and anything larger than this size right here will stay on top, and anything that's smaller will go through. So we can keep all the small oysters with the small oysters, and all the big guys, they can go outside.
Where we saw in those mesh envelopes.
So as long as you remove the large oysters, the small oysters will continue to grow.
So it looks to me like you have a lot more oysters in here than you have outside in those ponds.
Actually, we have comparable amounts. Usually, this is just the smaller ones, and you'll have higher numbers in here. But as they grow, you'll get less and less, like surviving to be large. So there's always going to be more in here. But once you get them out there, those are your survivors.
Gotcha. So like on average, about what percentage of them survive this stage?
After upsetting, it's like 30% of them survive, maybe sometimes more to 50% of them will actually be able to make it to be sent to be adult oysters.
Turn your love of the ocean into a lifelong career. Join NOAA, the National Oceanic and Atmospheric Administration, as we unlock the secrets in the deep oceans, track rapidly moving storms, model climate trends, protect and preserve our marine resources, and so much more. It's all in a day's work at NOAA. Find a career that makes a world of difference, enriching life through science, service, and stewardship. NOAA.
You're watching Voice of the Sea. One of the hardest parts of culturing oysters is raising the algae for them to feed. Keone helps me to understand about the algae and also how to grow them.
My project as a grad student, what I'm doing is working with multiple crosses of Pacific oyster, and essentially trying to find the best species that would be most efficient in growth and size.
Oh, wow.
What we can do is go over and take a look at how it's done before we start setting them.
Yeah, let's go take a look.
So essentially what we have here is 5 different crosses of the same Pacific oyster species, and what we're trying to do is trying to find the best species of oyster that will grow the best, that is most efficient as far as having put the less amount of resources into it and get the best yield.
They're all Pacific oysters, but you have different strains coming together and you're mixing them to find the one that's going to grow the best with the least amount of resource input.
Yes, and essentially in the best conditions that we here in Hawaii have. What you would see if there was larvae in here would be the algae, which would essentially settle, and it takes a while, but what you would see is really small, fine, it looks like sand almost.
Oh yeah, I can see some.
And those are the larvae. And
oh wow.
From when they're spawned to maybe about 3 to 4 weeks around there, they'll be swimming. But what's really interesting is that when they develop an eye spot or a foot, that kind of indicates when they're ready to settle. And so they'll kind of form a vortex, and then it's more or less an indicator of knowing when to set them. So by seeing that and seeing the size of them, we'll then know if they're ready to move out to be set.
And can you see their eye spot or their foot by looking at them?
No, it's all microscopic. Sorry, yeah. So it would be between 75 to 200 microns within there, and it varies.
So do you pick them up and look at them under the microscope?
Yes, we take a small sample, a random sample, and kind of look at them. And most of them you'll see inside there, so we'll just kind of tap it and let it, most of them try and settle at the bottom. And then from there we'll just place it on that slide.
There's a tiny grid on there, so you would count how many are on the whole entire slide?
Yes, on top of the entire slide. And the grid is kind of to help you, when you're counting, to know where you're at as far as rows and columns.
And can you tell the difference between the strains by looking?
No, not at this stage. I don't think even later, but as far as under the microscope, you can't really tell.
Do you have the microscope here?
Yes.
Let's go take a look.
All right. This is regular 70% alcohol, and we'll usually put this in to neutralize them from moving around. Especially when you're doing number counts, it's really hard to keep track of the ones that you've already counted. So the alcohol is a good way to neutralize them without having them die.
Oh, so it doesn't kill them?
No, it doesn't kill them, yes. So some of them you'll still see swimming around, but majority of them will be visible.
I just see kind of like a round shell and then a hook on the top of it.
Yes, so essentially what you're looking at is this right here. That round spot is the ventral area, and that umbel is that hook that you're looking at.
Yeah. And so where will their eye spot come out?
Their eye spot, at this stage, you'll still be transparent, so you'll see a black noticeable dot right around the center of its body. And later on, you'll see a foot which will develop out through the ventral part of the oyster.
So when we're in here, this looks a lot more like a science area than when we were outside. Can you show me around? What are some of the equipment that you have?
Inside here, what we have is different types of algae, and it looks nice and colorful, and pretty much is just different types of algae. So what this is for, this is pretty much how we get our oysters to keep growing. You know, this is their food, and You know, start from the bottom, growing the algae important, and feeding them is important. So there's different types of algae that we grow, and basically the reason why we grow so much different algae is because at different stages of the oyster's life, you know, some algae might be too big, and they need smaller things that are consumable for them.
So from what I know about small, like planktonic marine organisms, this algae growing area is probably one of the most important things about your operation.
Definitely. If I'm not sure if you've seen already, but there's a lot of algae bags outside, and just big, different colored bags of algae, and pretty much that's, you know, if we don't have that, you know, the oysters don't eat, and everyone's got to eat. So yeah.
Can you tell me a little bit just about how you got interested in studying the oysters?
I'm from Hilo, born and raised, so I was really interested in the ocean and never thought too much about aquaculture, but growing up, I've had the chance to work at fish farm in Oahu, and that kind of just sparked the interest of wanting to get in the whole field of just doing stuff with the ocean, but it's sustainability and production. Those things kind of really drew me to here, and kind of hoping to build awareness as far as local kids like myself, and in high school, you know, you really don't get opportunities to see this kind of things unless it's, you know, flashed out there, which it isn't. So I was fortunate enough to get in this and get a foot in the door.
So maybe what could you tell other students that are interested in taking your same path? What do they need to do?
Just be passionate about it, you know. That I feel will get you up day in and day out to get out here, but take advantage of professors, teachers, and resources that are made to them.
So you're getting your master's degree right now in aquaculture?
Yes, in tropical conservation and biology.
Wow.
So,
well, good luck with your degree
thank you.
and
Thank
your
you.
research.
Yes, thank you.
Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org. You're watching Voice of the Sea, learning from experts across the ocean.
Algae culture is a really important skill to learn if you want to work in aquaculture or marine science, and these days if you want to work in bioenergy, because as you know, they're making biofuels out of algae. So having a basic understanding of how to select strains of algae, how to grow the algae, and how to process it is really important. And right now, if you're an algae culture technician, that's actually a very hot job, and you can get hired $40,000, $50,000 straight out of an undergraduate program.
To grow algae.
To grow algae for research purposes, or to do it in an aquaculture facility, because this is the basis of everything we do.
Why is that?
Well, because almost all our animals depend on algae as a food.
So, Michael, you've just been hired here to work in the aquaculture facility, but you used to be a student here at UH Hilo, so what are you doing now?
Well, I studied marine science at UH Hilo and emphasized aquaculture. Actually worked with Maria back in '06 and loved it so much, loved aquaculture, that wanted to pursue a career in it.
Right on. So where are we standing now?
Right now, this is our bag system. After the algae leaves the lab, we bring them out here and we start these bags. We kind of briefly talked about the types. Well, this is our Catossaurus side, and this is our Isochrysis side. The Isochrysis is better for the smaller babies, but the combination of the two provides an optimum diet for them. So the way this works is actually we have to pasteurize the water and all the nutrients that go in here, because it has to be completely sterile, or else the bag will crash and we got to start over again. So over on this side over here, we run our water, we heat it up, and then we do a quick chill to prevent any bacterial growth. And then it passes through a series of filters as well as a UV light to kill anything else. And then we add nutrients to it, and then it's all ran into these lines here. It's all pressurized, and so using these valves you can adjust how much water and nutrients is going to each bag. They fill up to basically an overflow point, and then they flow down into the second set of pipes over into our 2 holding tanks here. And they will collect in the 2 holding tanks, and then the beginning of each day we will pump however much we need of each type into that main tank you guys took a look at before, and then we can feed them out to the oysters. And this is what they look like when we first start them. They start out low. We're not harvesting this one, and we build its density up as it goes up the tube here. And then when it gets to harvest, hopefully it's this dense, nice color, and we can harvest it.
So they're just using the sunlight that's coming through the wall of the bag
and the nutrients that we add to the water.
And photosynthesizing away.
Exactly.
And then you guys can visually check it out, and it looks pretty easy to tell if something was going wrong. You're making observations.
Yeah, well, you can see these bags, these are older bags. You start getting a little bit of growth on the outside. And then we'll test this bag, and we'll see where it's at, if it's got too much bacteria in it, or the cells are too dilute, or we got protozoans or different things in it that we don't want it. We'll dump it. And
protozoa would be an animal that's munching your algae.
Right. Yeah. Something that will that we don't want in with the oysters. This is a great area because it's great for learning. Anyone that shows interest in this kind of field in aquaculture, this is a perfect opportunity for them. Aquaculture is the up and coming new thing.
Why?
Because food production is going down. With the world doing what it's doing, we're going to need fish in the future. The oceans can't provide the world with food. And so aquaculture, as well as agriculture, in my opinion, is the next step.
So, Forrest, you're the hatchery assistant here?
Yes, yeah, I started working here about 2 years ago after I graduated from the Marshall Islands. I came here and started going to school and working for Maria Hawes on these oysters.
Great. So you want to show us around a bit?
Yeah, so what we have here are different life stages of the Pacific cupped oyster that we export. This is 4th week, so when we get them in, they're 1 week old, and there's a certain screen size for 1 week. Like these are 105 micron, and that's for 4th week. For 1st week, we have 41 micron screens, and they have certain flow rates. If you'll notice over here, the algae that's dripping in comes from this reservoir tank and feeds the oysters.
The University of Hawaii's Sea Grant College program, focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
The Curriculum Research and Development Group in the College of Education at the University of Hawaii at Manoa. CRDG has been providing quality educational programs and services for over 40 years, serving students, teachers, parents, educators, and experts around the world and here in Hawaii. The Curriculum Research and Development Group, improving schools, improving education. CRDG,